Our job was to build an outer space Olympic training center. We have 3 zones, each with a different centripetal acceleration, which is our artificial gravity, to provide a different experience. In Zone 1, we have Earth-like gravity, 10 meters per second squared. To continue with the home-like features, this zone includes living and eating quarters, an Olympic-sized swimming pool, basketball court, and track. We created Zone 1 as the largest to ensure that athletes can feel comfortable and busy with their daily lives. In Zone 2, we lessened the force of our artificial gravity to 5 meters per second squared. This area is our rehabilitation facility, a place for athletes to give their hardworking bodies a bit of a break. With less resistance on their joints, they can utilize the gym center for ensuring a full range of motion in each of their exercises. We also include jumping pits and treadmills for even more activities with less impact. Trainers and therapists will be available to sort out any aches and pains. Zone 3 will have a centripetal acceleration of 15 meters per second squared. A perfect area for resistance training. Much like walking around with hand or ankle weights, it is an easy way to work yourself a little harder with simple movements like walking. In addition to the extra resistance you get by walking or running around the center's track, there is also a weight room and throwing facilities for anyone looking to improve body strength in these areas. As you can see, Zone 2 and Zone 3 are a little smaller than Zone 1. We did that so that people would not spend an excessive amount of time exposed to artificial gravity forces that their bodies are not completely used to, and that they would utilize the Earth-like gravity more. In order to keep each zone moving fast enough to create the centripetal acceleration belonging to each zone, we had to apply the accelerations and radii to the equation centripetal acceleration equals velocity squared over the radius. Doing this problem, we could solve for the correct velocity. For example, to solve for the velocity needed for Zone 1, we plugged in our centripetal acceleration, which was 10 meters per second squared, to equal velocity squared over 400 meters, our radius. Then we multiplied 10 and 400 and square rooted that number, which was 4,000. After square rooting that number, we were able to figure out the velocity needed to keep our zone moving fast enough so that all of our items would stay on the floor. Each individual zone was not the only velocity we needed to find. We also had to figure out the entire station's orbital velocity. Using our given amounts for g, the mass of the station and the Earth, as well as the distance between them, we were able to plug those in to the force of gravity equation. With the force of gravity, we then could find the velocity for the entire station using centripetal force equals the mass times velocity squared over the radius. We also calculated the period for each zone in the entire station as well, another way to represent how long it takes for each rotation. The equation we used for this is velocity equals 2 pi times the radius over the period. Overall, our station will be habitable due to the artificial gravity we are creating from the centripetal acceleration. Because of Newton's law of inertia stating that an object in motion stays in motion, we have to create a force that sends our floor and what the floor is pushing against into a constant rotation towards the center of the circle, instead of just moving in a straight line away from our station, which is also known as the centrifugal force effect, as shown in this picture. The centripetal acceleration we are creating in each of our zones is based off of how the Earth rotates around the Sun and how the Moon and satellites rotate around the Earth, which is the gravitational pull. Instead of gravity creating a centripetal force in each of our zones, however, we have the tension from spinning beams connecting the outside rings of the station to the center. In either case, The floor of the station presses against the object's pressing back, which is equal and opposite action, providing the centripetal force that holds the station and everything inside it in its circular path, all while gravity pulls the station through its circular path as well.